Hey everyone, let's take a look at number 16 in section 4.2. We're defining the max and min for this function or something very similar to it on the interval, in this case from 0 to 2 pi, or again, something similar to it. So how do we do that? In order to do that, we need to check the value of this function. It's a continuous function on a closed interval, so we're guaranteed to have a maximum minimum. Where do they occur? Either at the endpoints or at the critical points. So we need to check the value of this function at the endpoints and at the critical points. In order to do that, we of course have to find the critical points. And so your support should be the derivative of the function, right? Derivative of 4 theta with respect to theta is 4. The derivative of -8 sine theta is going to be -8 cosine theta. Remember, the derivative of sine theta is cosine theta. So this is the derivative. It's never undefined, but it is equal to 0 when what? When 8 cosine theta is equal to 4, or when cosine theta is what? 1/2, 4 divided by 8. When is cosine theta equal to 1/2? Well, if you go to the unit circle, I don't have the unit circle with me, but you might want to double check and look at it. It's where the x coordinate is equal to 1/2. And the x coordinate is going to be 1/2 right there on the unit circle, which is going to correspond to that point there, which that angle right there is going to be pi over 3 radians, or coming down here, this one, again on the interval from 0 to 2 pi. So from 0 to 2 pi, coming all the way around there, we're going to be down here at what? 5 pi over 3. Again, if you have the unit circle, you can see these values. That's the critical points for this function just on the interval 0 to 2 pi. If to change the interval, of course, the critical points can change as well. Okay, that's the first step. Second step is now we just check the value of the original function, not the derivative, but the original function at these endpoints and at these critical points. So it's just evaluating it. And the way you would show that for support is a simple table. Here I've got the value of theta. Here's my endpoints 0 and 2 pi. My critical points pi over 3 and 5 pi over 3. And then the value of y, which remember y is 4 theta minus 8 sine theta. So if I plug in 0, 4 times 0 is 0, minus 8 times sine of 0 is 0. So this is just 0. I plug in 2 pi, 4 times 2 pi is 8 pi. Sine of 2 pi is also 0. So this whole expression is equal to 8 pi, which is about 25.13. Now pi over 3, I've got 4 times pi over 3 minus 8 sine of pi over 3. Well, sine of pi over 3 is the y coordinate. At pi over 3, the y coordinate is way up here. It's at square root of 3 over 2. Sine of 5 pi over 3, down here, what the y coordinate, right, is the sign. It's negative square root of 3 over 2. So make sure you note that distinction, right? Sine of pi over 3 is positive square root of 3 over 2. Sine of 5 pi over 3 is negative square root of 3 over 2. So when I plug it in at pi over 3, this is square root of 3 over 2. 8 times the square root of 3 over 2. The 2 divides into the 8 4 times. I get 4 square root of 3. Of course, here's just 4 times pi over 3 is 4 pi over 3. This is the exact value here. Can't really simplify this any, but we can use a calculator to approximate. And I did that. You can see I've done that in this TI-84 calculator here. There's the 4 pi over 3 minus 4 square root of 3, and that comes out to be about negative 2.74, right? Similarly, I evaluate the original function at 5 pi over 3. Here I'm taking sine of 5 pi over 3, which is negative square root of 3 over 2. So minus a negative makes that positive 4 square root of 3 as opposed to negative. Of course, here 4 times 5 is 20 pi over 3. This is the exact value. Approximate that with my calculator again, as I've done here. And you get it's about 27.87. So now we have our list of potential candidates. One of these is the max and one is the minimum. Well, what's the minimum? It's the smallest number. The smallest number, of course, is the negative 2.74. So this is our minimum. So in achieve, they write it y min. On a test or something, I'll probably just say minimum. What's the minimum? And you want to give the exact value. Okay, you've given it here, so it's okay to give the approximation, but achieve wants the exact value. So you have to give the exact value. Do need the approximation so we can compare, and see which one's the biggest and which is the smallest. The maximum value, of course, is 27.87, just a little bit more than that point or that value there. And so that's the maximum right here, 20 pi over 3 plus 4 root 3. Okay, And so hopefully this explains how, again, to show support in these type problems where you're finding the max or min and or min for a function, continuous function on a closed interval. Okay, hope this helps with this particular problem.